Hey, welcome to TXAPA Live. I'm Jim Warren. We're glad to have you here today. Today is April the 30th. It's been a whole month of these, and we're glad to have you here. We've got a real busy program today, and we want to make sure we get everything in, so let's go ahead and get started. Remember, these programs are being recorded. Since you registered by email, you'll get a link later on, so you get a copy, or you can access the presentation later on. Remember, we're on Tuesdays and Thursdays at 2 o'clock. Tuesdays is our news and info program. Thursdays is our technical program like today. We'll be using the GoToWebinar feature, or the GoToWeb, just the camera on this GoToWebinar. So if all you see is a screen like this, just double click on the webcam. It should pull up full screen. That doesn't work. At the bottom right-hand corner, there's a little double arrow. Click on that to expand that out and you'll get it full size. Remember, we want your questions. You can put questions in at any time. Just go to the box, type your question in, make sure you hit the send button. That'll pop up right down here on my screen. I'll read it off as we're going through with our speakers today. So again, glad to have you. We want you to participate. And just a thought, if you've got an idea for something that you'd like to see on TXAPA Live, go ahead and put it in that box and we'll take a look at it and see if we can accommodate you best we can. All right, here's where everything is on our website. It's texasasphalt.org. Right on the front page there, bottom middle, click on that link and that'll take you, whoops, a little bit too fast on the trigger. That'll take you to our TXAPA Live page. Right at the bottom of that page, there's a blue bar in there. If you double click on that, you'll get all the previous programs that we've done, and so that's where they're always going to end up, and we're good to go. Okay, so again, welcome. Glad to have you here. Today's safety share is part of the Joint Workforce Safety Plan that was developed by a number of major industries here and associations in Texas, and they put something together. I think it's been almost a month now that we've had this out there, and we're still trying to put it out. Jenna and Emily with TXAPA staff have put together some infographics. We wanted to just share these with you. They're available right down there at the bottom, right about there. There's a link, and you can double click on that link and you'll find all those safety shares. They're in PDFs. You can download them. You can attach them to your own social media. You can print them out. You can do whatever you want with them just to get the word out. We've got one on why road construction is continuing. We've also got one on just general employee safety and health. Nicely done. We've got the 10 basic general guidance rules everybody needs to be following. Again, really good content there. The whole document is available at our COVID website as well. We've got one on cleaning, disinfecting surfaces and surroundings. We've also got one for personal hygiene, which is cleaning and disinfecting yourself. Regardless of what you see on the internet, don't drink disinfectant. Well, Chuck might, but it's called bourbon, but we won't talk about that here. But again, washing your hands, all those critical things, covering yourself if you're coughing, stay at home if you're not feeling good, notify your employer. And when you do return to work, there are some criteria that have been set out how to do that the right way. Again, notify your employer. We don't want to put anybody at risk. I think one of the main things we're starting to see this COVID thing kind of plateau. We certainly want it to go down. We don't want it to go up. So all the good stuff that we've been doing, we need to continue to do so we can get back to work. I need a haircut. So do a lot of people, and I think that's why Ryan's got a ball cap on today too. So we'll get to that in just a minute. So again, glad to have you here. Extraordinarily having a good time. Remember, questions at any time, type them in the box. We'll get them answered. Today's program, today's lineup is we're going to be talking about thermal profiling. We've got one of our guests today is Ryan Barborak. Everybody knows Ryan. He's with TXDOT. He's going to be here today to talk with us. Excuse me. I don't have COVID. I just got a dry mouth. And we also have our Thursday host, Chuck Fuller. Chuck and Ryan, why don't you guys say good morning, good afternoon to everybody?
Appreciate that, Jim. Really appreciate being here. And we're going to be here talking about the text method 244 a little bit, but I think there's a lot of stuff that's got to go into before we get to the test method. And that's the reason why we asked Ryan Barborak to be here. Ryan has been a big proponent of thermal segregation. He was a big proponent for being able to establish a shear test and establish a bid item for tack codes. So Ryan, I really appreciate the fact that you're going to spend some time with us and kind of go through exactly your thought process on the thermal segregation and what it's all about and what we need to do as industry to be able to ensure that we get more durable, longer lasting pavement. So Ryan, I'm going to turn it over to you. It's your deal. So after you, Ryan.
All right. Thank you, Chuck. Good afternoon, everybody. This is Ryan Barborak with the Materials and Test Division. First, I want to start by saying thank you to TXAPA. Thank you for those on the call. Really appreciate your interest in these very important topics. And like Chuck mentioned, today's topic is going to be thermal segregation and also more specifically the test procedure Tex-244, which is our test procedure for conducting thermal profiles. We have sent that procedure out to industry for review. I just wanted to kind of get on the line and share some of the ideas behind why we put the information that we did in that test procedure. But before we get into that, I wanted to kind of just briefly talk about thermal segregation. And so first question is what is thermal segregation? And if you look at the screen, you will actually see the definition that we have regarding thermal segregation. Now, that's a long definition. It's actually much more simple than that. Really, what thermal segregation is basically hot and cold spots in the mat. What the concern is that when you have cold spots in the mat, you don't get compaction, okay? So this leads to high air voids in those areas that are cold. So what are some of the symptoms of thermal segregation? Well, sometimes you'll see what you see on the screen in the picture on the right-hand side. You'll see what we call these localized spots of coarse texture. And these spots can hold water after a rain event. What's our concern with these cold spots and therefore thermal segregation? Our concern is that it's premature failure due to fatigue cracking, raveling, and moisture. So in other words, we're concerned about the quality of our mat because we know that thermal segregation will impact that quality and may result in not us being able to achieve the design life that we need. In addition to that, another concern would be increased roughness. As you can imagine, if you have an area on the mat that compacts well because it's at a hot temperature, and then you have an area on the mat that's cold and doesn't compact, it's going to cause a bump. And so another concern that we have in regards to thermal segregation is increased roughness on our roads. And we pride ourselves in long-lasting, durable, smooth pavements. And really, the concept of thermal segregation is basically the same as insufficient compaction. So some general rules of thumb that I think are very important for us to consider when we talk about thermal segregation. And what we have on the screen is you'll see for dense graded hot mix, a 1% increase in air voids above a baseline of 7% results in a minimum of 10% decrease in the pavement life. So again, what does that mean? That means that if I consider a baseline of 7% air voids, when I go to 8% air voids, I can expect at least a minimum of 10% decrease in my pavement life because of the increase in the air voids. Furthermore, whenever we start talking about temperature differentials, a 25-degree Fahrenheit temperature differential results in approximately 1 to 2% more air voids in those areas that are cold. So as you can imagine, if we talk about a temperature differential of, say, 50 degrees Fahrenheit, we can expect upwards of 4% more air voids in those cold spots. And it's that is the concern that we have in terms of affecting the durability of our pavements. And then another good point to know is that no significant compaction occurs below cessation temperature of about 175. So once the mat gets to about 175, that's it. All bets are off. You're not going to see any significant compaction.
You know, Ryan, I had just a statement there. You know, I think the issue is not, you know, I think the thing that to get the part is you only have to have a couple bad areas for the pavement to go bad. It's not like the whole pavement is going to go. But if you get localized areas that are failing, well, guess what? The whole pavement then goes back into the program for rehabilitation because now it's not working. So, you know, it's one of those times when, you know, you can do everything great 95% of the time, but those 5% of the time, we could be having problems, and those things could be causing us to have to go back earlier than we should. Chuck, did you want to weigh in?
Yeah, absolutely. So Ryan, when you talk about you got your percentages up there. So I did a little research. NCAP produced a white paper, and it's about durable pavements. And in that white paper, they did a life cycle cost analysis between two alternatives. One with the alternative of 92% density, and the other one was 93% density. That's in-place density. And the life cycle cost analysis that they came up with is just that 1% and that density could equal up to $1 million in the paving process. 8.8% would go toward flexible pavements and the life cycle cost analysis. And that white paper is very detailed, has a lot of information in it. And if anybody wants to see it, just let me know. NCAP produced it. I have a copy of it, and it's a great paper to take a look at. Just that 1% increase in in-place density. And the other thing about that, when I was doing the research, was that this is not a new thing. Dr. Epps produced a paper in 1980 called Pavement Fatigue. And he showed that same percentage, Ryan, that you're talking about, 10 to 30% for every 1% increase in air voids. So, I mean, holy smokes, it would seem to me that if we could just get that 1% more density, you know, then we could really move the needle, especially in the life cycle cost analysis. So I thought that was real interesting that there's a lot of data supporting what you're talking about.
Mm-hmm. And Jim, I know that you still have the slide up on the screen that shows that picture on the right-hand side. You're exactly right. When you look at this picture, what it's trying to demonstrate is exactly what you were talking about. It's those areas that are number one, show a pattern, and then number two, it's not the entire mat, as you mentioned, it's those localized spots. So when you look at the arrow, in between those arrows, that mix is still performing well. But the reason why we're having the problem, or the reason why we're going to have to go in and re-overlay this section of pavement, is because of those cold spots, right? So
Yep.
that was a very good comment that you mentioned. And so the next question is what do these cold spots look? Well, you know, we can't see heat, okay? We can see physical segregation, we can't see thermal segregation. And so what you see on the screen is an actual thermal image taken by the thermal camera that shows you, in this particular case, what thermal segregation looks like as a result of end of load. So as you can imagine, when we have end of load segregation, you end up having basically cold mix that enters the paver and then essentially gets smeared on the pavement surface. And so it's these spots that we're concerned about, because if you look at closely, and what I've done is I basically went through FLIR analysis and actually looked at the temperature differential on this image, and you can see that the temperature differential in the blue area versus the red area is somewhere right around 80 degrees Fahrenheit. So remember we said for every 25 degrees, 1 to 2% more air voids, we can expect upwards of somewhere right around 6% more air voids in those blue spots. So that's our concern. Furthermore, the second concern that we have, and you'll see on the next slide, is basically paver stops, okay? Paver stops can be just as bad as end of load segregation. Why? Because what you're seeing on the screen is an actual shot taken after the paver began to advance because it received more mix. But during that time, as that paver was sitting there, what you're seeing is that number one, the screed heaters were left on. So in that white/red area, you're seeing that basically the temperature in those areas is upwards of 332 degrees Fahrenheit. So you're essentially burning the mix. And then just behind the screed, because the paver's in the way, you can't get the mix compacted. You can see that the temperature is somewhere right around 190. So we set 175 as our cessation temperature. We're approaching that to where basically we're not going to be able to get compaction in that blue area simply because the paver is in the way. There are several things that we can do to minimize thermal segregation. I wasn't going to spend a lot of time on this slide, but these are some very good best practices to minimize that. You have what we call the material transfer vehicle with remixing capability. These have shown to provide really good remix. Because you're able to remix the mix, you're able to, any of those cold areas, if you will, get remixed, if you will, and then you're not subject to having those cold areas, that cold mix, if you will, being smeared on the surface of the pavement. So the MTVs with remixing capability do a good job of that.
Just jumping in there, I think, that's a real key thing is you're going to get some surface cooling on the mix in transit. The longer the haul, the more that those MTVs, or even whether they're using a bottom dump or whether just an end dump or a flow boy, they're going to help us even the temperature out. By the time that mix gets back, into the hopper, through the paver, underneath the screed, anything that we can do. And again, most of the time you'll never see that with your eye, but it'll be there, and this will help sort things and kind of even things out.
Something else, Ryan, is that all those items right there are covered in the specification. You have identified those items, they're covered in the specification, and specifically they're covered in the quality control plan. You worded the quality control plan to where you're going to have to explain, the contractor's going to have to explain to TXDOT, how they're going to be able to minimize the segregation. And I think the rewording of your quality control plan, adding those items, about segregation, material transfers, speed of the paver, continuous pave operations, those are all addressed with those items right there on that slide. So I think it's real important that you address that. You will here in a minute about the quality control plan and the new specification.
Got one question that just came up. Do the same ratio of air voids and temperature apply when using warm mix or a compaction aid? And that is a good question.
Great question. So the information that you saw on the previous slide was in reference to hot mix and dense graded asphalt. So I would say that there is a chance that, yes, you would see an increase in air voids as the temperature decreases. But keep in mind, we have set the requirements for warm mix from 215 up to 275. And I think one of the key benefits of using warm mix that you see on our list here of things to minimize is that when you start at lower temperatures, it takes longer for a lower temperature to cool than a hotter temperature to cool, right?
Yep, absolutely.
And so to answer the question, my feeling is that as long as the mixed temperatures above 215, we should be fine. That's what's outlined in the specification. But also keep in mind that because you're dealing with a lower temperature, it will take more time for that mix to drop to 215. Furthermore, you can see, so we talked about warm mix. Insulated trucks also made the list. We have shorter haul distances, can help to minimize thermal segregation. Consistent placement operations. Chuck, you alluded to that. We did cover that to some degree in our quality control plan that we'll talk about next or up later on in the presentation. Utilize the pay-by-hour data. What does that mean? That means utilize it, right? Use it to your advantage. Use it to better your paving operation. Use the data. Proper overlap of windrows is also important. Pave at higher temperatures, ambient temperatures that is, and minimize handwork. So let's kind of talk about the specification for a minute. What is the specification? What does TXDOT specification say? It says use a handheld thermal camera or thermal imaging system to obtain a continuous thermal profile in accordance with Tex-244. That's what our specification says. How do we classify thermal segregation? This on the screen now is TXDOT's classification of thermal segregation. So there is no thermal segregation when the temperature differential is between 0 and 25 degrees Fahrenheit. You get into moderate thermal segregation between 25.1 and 50 degrees Fahrenheit. And then we have severe thermal segregation when it's greater than 50 degrees Fahrenheit.
Got
So I'm going to switch gears.
One more statement, just to jump in there. I guess this is a statement more than a question. It said also lower temps reduce AC absorption, so more effective asphalt is available as well. Thanks, Harry.
Very, very true. So now let's talk about the changes that we proposed to Tex-244. Okay. So first off, when you look in Tex-244, you have, like we said, what the specification requires. There's two ways to obtain that thermal profile. You have a thermal imaging system and you have the thermal camera. Okay. So I'm going to first talk about the thermal camera and the changes that we proposed. When you look at, and if you don't mind going to the next slide.
Oh, I'm sorry, I was reading another question.
Okay.
Let me jump in there real quick. How do we determine the effect of thermal segregation on mixes where we don't measure in-place density, i.e. TOMs and PFCs?
So in those particular mixes, right, the concern on TOM mixes, we do in the new specifications, we have included more testing with our drain down, if you will. So that's the way that we try to look at how we know that if we don't get compaction on our TOM mix, we know that it's going to be more likely for the mix to drain water, which is exactly what you don't want it to do, because the whole reason why we're putting a TOM mix on top is because we're trying to seal that surface, right? We're trying to seal off any water from getting into the pavement layers underneath. In terms of PFC is something that we are concerned in terms of thermal segregation, because our concern with PFCs would be raveling. Okay, so if you're not able to get that PFC seated, the aggregate, the mix itself seated, it's more likely for it to ravel at a future date.
Yep.
So, so going back to the changes to the thermal camera test procedure. So one thing I wanted to mention is that yes, when you look in the test procedure itself, you will see that there's a lot of red. Okay, there's a lot of red on the thermal camera section, right? There's a lot. But what we have to keep in mind is that when you start to read it, what you'll see is that it is very similar to the guidance document that we published about 4 years ago. So we published a guidance document on how to conduct the thermal profile in April of 2016. It's also the same procedure, or very similar in terms of what we cover in the level 1B. So for you to get your certification, you have to demonstrate how to conduct a thermal profile. So it's very similar. Now there are some key changes, and I was going to focus on those key changes. Number one is that it included a spotter. Okay, so we want a spotter to assist that person that's conducting the thermal profile because of safety reasons. Okay, we need somebody to be on the lookout for that person conducting the thermal profile. So hence we included a spotter. In addition to trying to make the test a little less complicated, so if you look at the guidance document, we say to concentrate on that temperature on the top left corner. Okay, we put a lot of emphasis on that. Instead, what we're saying now is that it's not so much about the temperature on the top left corner, it's more so about the colors on the screen. Okay, and so on the next slide, you will see what we're talking about in terms of the abrupt color change. So basically, this is an example of it. So this is what we're looking for when we're conducting a thermal profile with the thermal cameras. Okay, this is an example of what you're looking for. So you're not looking at the top left corner anymore at the temperature, you're looking more for colors. If you go back to the slide for a minute, Jim,
Okay.
In addition to that, and we included pictures of thermal segregation. So we have a whole bunch of pictures in that document to show what thermal segregation looks like in terms of what it's going to look like on the camera screen. And then this is very important. We also propose to include paver stops in the analysis. So
That's
if you
new.
can now advance, Jim, unless there's any question, to the next slide.
After that one? There we go.
So, yep, ready for this one, because that previous slide was basically showing you an example of an abrupt color change. So in terms of the thermal imaging system, we did get feedback from suppliers suggesting that the profile as proposed could cause some major problems with the analysis. We realize that our goal is to have a test procedure where all thermal imaging systems can meet it, okay? So what we're gonna do is, after we get feedback from industry regarding the changes that are currently being proposed, we are going to propose that the current method that's used for the thermal imaging system be used, except we're going to propose not having that 2-foot offset, that is currently in our thermal imaging system profile.
And that will allow some of the other manufacturers to jump in there.
That's correct. That will allow some of the other manufacturers to be able to, so that their devices can be used to meet our test procedure.
Gotcha.
Some additional key changes, again, too, that I'd like to stress is that the system must remain on during the paving operations. So the idea behind using the thermal imaging system is that it doesn't do us any good if it's not on, right? So what we proposed in the test procedure was, whenever you start, from the time you start to the time you finish, we want that system on, so it's collecting data so we can make use of that data, if you will. And then we also proposed including paver stops in the analysis.
Okay, good deal, good
So,
deal.
Ron, when do you think that the test procedure to include the other suppliers will be accomplished? I mean, is it after we go through 244? Are you going to resubmit 244 to industry, or what's the direction we need to do with 244 now?
So that's correct, Chuck. So whenever we get the comments back, we're going to address the comments. We're going to send a second version, if you will, with those changes that we just discussed, for additional comments, if you will. And in the meantime, the other thing that we're going to work on is our template that we use to record the data. We want to make sure that those other systems have the ability to record their data within Site Manager. So we're going to be working on that kind of all at the same time, if you will.
All right, so
I'd say to answer your question, Chuck, I'd say within a couple months at the latest.
Yeah, so going into the third or fourth quarter, we should be able to have this thing hammered out, right?
That's correct.
Perfect. All right, thank you.
And just a reminder, if you have any questions at any time, just go ahead and type them in, and we'll get them out to Chuck and Ryan. Thanks. Go ahead, Ryan.
All right, so now I wanted to focus a little bit on the impact of this test procedure to our specifications, okay? And so, as Chuck mentioned, in the new specifications that we have currently under review by industry, we did use keywords in the placement section of the quality control plan. Production rate, physical and thermal segregation, and speed were those keywords. Again, the goal with this is to basically have continuous paving operations, because that can help us minimize thermal segregation. In addition to that, what I've done is, on the next slide, I've broken it down into thermal camera versus thermal imaging system. So what's the impact that Tex-244 is going to have in terms of the thermal camera? And so what we put in the new specifications meaning 3076 and 3077, that's already published, if you will. And then any of the new specifications, we stated that the segregation density profiles and thermal profiles are to be performed in the presence of the engineer unless otherwise approved. Okay, so that is actually in the spec in 3076 and 3077. So one way to look at it is that the engineer could be your spotter, right? Could be your spotter. We did not.
Yeah, I was going to ask about that. Because that makes the most sense. He's out there, he can watch keep
That's
an
right.
eye on things, but also he's there monitoring what's going, killing two birds with, not, killing is the wrong word, but getting two things done at the same time. I think that's a great idea.
That's right. That's right. And so in terms of the testing frequency, we did not change that. That has always been what you see on the screen. Contractor, 1 per sublot, engineer, minimum of 1 per project. I just wanted to point that out. We did not change the testing frequency, but it's basically the same as the former spec. So if we go on to the next slide, this is where I think it's very important for everybody to understand. So as we stated, we are proposing to have paver stops included in the analysis when we use the thermal cameras. So that means that if thermal segregation, whether it's moderate or severe, is determined, you see on the screen what the consequences are, if you will. And again, the idea behind a paver stop is that there's nothing wrong with the paver stopping. We all know it's going to happen. It's a matter of how long does that paver stop? What temperature does that mix that's uncompacted behind the screed get to before the operations start up again, okay? And so because we're now including paver stops in the analysis, we kept the verbiage in the specification exactly the same as it was in the previous specification, but just take note that corrective action, if it's moderate segregation, so what we mean by that is 25.1 to 50 degree temperature differential. If moderate is observed, we need to take corrective action. And if the moderate thermal segregation is recurring, and we also need to evaluate those areas by performing density profiles. In terms of severe segregation, you can see that it's more severe too in terms of the penalties. Again, this was taken straight out of the spec. And again, this is the same verbiage that was used in the previous specification, item 341 or item 344. But the idea behind it is that if you see a temperature differential greater than 50, no production or placement bonus is allowed. So basically your pay factor would be a 1.0. Our spec says to suspend operations and take immediate corrective action. You need to evaluate those areas that have severe thermal segregation with density profile, and any areas that both have a density profile that fails and have severe thermal segregation may be subjected to remove and replace.
That's big.
I guess the big deal here is that the engineering witnesses it. That's what I'm, I know that you're taking the old spec and just kind of putting it out there, but with the engineer now witnessing it and identifying them, I think that's going to help us really truly identify more, more out there, and just because they got extra eyes on it.
Yeah, I got one question here, or
Okay.
one statement. I'm battling a lack of haul trucks and constant paver shutdown. What would be some good data to back up my requirement for keeping the paver moving and limit cooling or overheating the mat? Current spec is if the mat reaches 235 or less, corrective measures must be taken. You following that? So again, he's asking, what would be some good data to back up my requirements for keeping the paver moving and limit cooling or overheating? One thing that I've seen in some other places, a formal job that I had, was if particularly on thin mixes and PFCs or open graded mixes, if you get stuck and you've got full hopper, you can ease forward a little bit and just kind of let the rollers get caught up a little bit and just kind of ease forward a little bit every couple minutes just to keep the mix from cooling off. Obviously, I mean, you had a slide earlier about they may be leaving their heaters on, particularly with thinner lifts. If they are having to stop, that'd probably be a good time to kick those things off, at least while you're stopped. So a little bit of screed management, if you will. But go ahead, Chuck and Ryan. Any comments on that?
Yeah, I guess my comments would be slide 7, right? Looking at slide 7, those ways to minimize thermal segregation, I think some of those would be applicable in this instance. Warm mix might be an option. But I do realize that sometimes the availability of trucks is a challenge. We understand that. And so, I think that we just need to do our best to ensure that we try our best to get continuous paving operations, because we know that thermal segregation is going to impact the performance of our pavement. Chuck, do you have anything to add?
Yeah, so there's a tool, there's several tools out there, but Jim Warren has put together a little spreadsheet, and it's on our What's New area of our webpage. And if you get cut down to 10 trucks, it'll tell you your maximum paver speed based on your width and your thicknesses to be able to do continuous paving. If you get cut down to 5 trucks, I would utilize those tools first. But in the most extreme cases, like if you have them bunched up, where you have 10 trucks come to you, and then you got to wait 45 minutes, and then 10 trucks come to you again, you got to wait 45 minutes, it's better to go ahead and make a transverse joint, empty out your paver, and start again. That's the very worst scenario, but I would much rather have that than have 300 or 400 foot of uncompacted material because of temperatures, and you're battling temperatures. So either utilize the tools to be able to determine how fast you can pave based on how many trucks you have, and or if they're coming to you in bunches and then breaking and coming to you in bunches again. I would do a transverse joint and empty out the paver and start again, just like you do every morning, or at the end of a shift or something. But that's what I would do to eliminate that 500 or 600 feet of uncompacted area.
Yeah, one more quick note on that. No, go ahead. Let's go ahead. I'll pick it up later on. Go ahead.
Okay, and so I think we're good with that slide, Jim. And so just to kind of wrap all this up, if you will, talk about the impact of the changes to the thermal imaging system on the specification. In terms of the specification, the only change that we made in regards to the thermal imaging system was we changed the minimum pavement surface temperature requirements. So, we realized that, at the time when we, former specification, we said when the roadway is dry and is at least 32 degrees Fahrenheit, we allowed paving to occur. You will see that the new changes, particularly in special specification 3076 and 3077, for 64, they're not that different, but we did change. We did break that, number one, into a table now, and number two, we realized that we need to speak in terms of binder grades, because going from a 64 to a 70, from a 70 to 76, it's going to get more challenging to achieve compaction. And so I guess the idea behind that change that you see in our specifications is that, just because our specifications allowed it didn't mean it was the best practice, right? In terms of that's the only change. Regarding the previous specification, we kept everything else the same. So segregation, density profiles, thermal profiles are not applicable, not required when using the thermal imaging system. We did keep the language, the engineer may suspend paving operations for recurring severe segregation. Remember, that's greater than 50 degrees Fahrenheit temperature differential, and you do not lose bonus for severe thermal segregation.
So there are some significant advantages, even though there's a significant cost to go to the system versus the camera, but there are some significant operational differences of moving towards the system rather than just the camera.
That's correct.
Okay. Chuck?
And Jim, I think that kind of sums it all up.
All right.
We can open it up to any questions anybody may have.
I got a couple of just real quick comments. In the specification, the new ones, especially with these thinner mixes, we also have the when you're using the SMA, I should say, in the dense graded, our segregation density profiles are now going to be temperature related. Instead of the paver stopping for 1 minute, we're going to have temperature related when you have to run a density profile. And it just goes back to what Ryan's been saying, is that we're going to concentrate on temperatures. So we have minimum placement temperatures on all the new specs. We have maximum production temperatures. You have now temperatures on density profiles for dense graded super pave SMAs. In other words, the uncompacted mat behind the paver, when it does stop, we're going to have to be running density profiles. Plus, you got to run one per sublot. So when you put it all together, the running with the camera is going to be a bear. I mean, the IR system or your thermal imaging system seems like that's the way to go on your surface mix. And I know, Ryan, you and Materials and Test Division have had several conversations about utilizing a thermal imaging system on these specialty mixes like PFCs and thin bonded wearing courses, and maybe even making it part of the specification. You want to just kind of just jump into that just a little bit so that we'll know what's coming down the pike here?
Mm-hmm. Sure, Chuck. So the idea is that for specialty mixes such as TOMS and such as PFCs, the idea would be to only require the thermal imaging system. And so being that we're opening up Tex-244 to include these other thermal imaging systems, right? You know, it's something that we would like to start the discussion with industry. What's industry's thoughts regarding that? Of strictly, you know, it'd be for specialty mixes, but in pretty much requiring the thermal imaging system and not even allowing the thermal camera at that point. So
we're going to need to talk about that.
Yeah, I think we should start the conversation right now since we have the new specs in front of us. And then also, Ryan, one other thing is that your presentation that you just given, we're going to be able to utilize that on our website, correct? We can go ahead and download that to our website so members utilize it.
Absolutely.
Okay.
Well, that'll be posted. That'll be posted with this program as well. We're running out of time. I've got a couple. One more question. There was a mention of reporting out into site manager. Not sure I understand that statement. Could you clarify that, Ryan?
So as far as site managers, so one of the holdups that we're having with the thermal imaging system is that the format of how you report the data is slightly different in the reports that we get with you know, one thermal imaging system versus another. And the reason being is because of the software that's being used. And so our idea is that when you go in and you look at the site manager template, you're going to have the option now to be able to figure out what format you need to use in order to input the correct data. So that's what that's
Okay.
about. That's what that comment
Okay,
is about.
good deal. Good. I think that answered his question. And Doug Zuber had made a couple statements. He's going to try to pull some data from a couple other states, including Illinois and Missouri, and get us some information that they're doing there. So thank you on that, Doug. Well, Ryan and Chuck, we have passed our appointed time slot for this program. We are just real pleased to have everybody spend some time with us today with TXAPA Live. We're going to have to pull it closed. I think we've tried to get most of our answers out there. Again, if you have any questions at any time, please feel free to contact Chuck, myself, or Ryan. We'll get you the answers you're looking for. Remember that specification is out on our website. You go to the home page, bottom right, it clicks on specifications. It's out there. Then you can download that and take a look at what we've talked about today. This presentation will be posted as well, so you'll be able to see it, and you can kind of go through side by side, see what we're talking about. Always looking for feedback, always looking for comments. Helps us, helps you. We've got a great partnership with TXDOT, and this is how we get things done. We talk about things, we work through them, we bring different ideas to the table, and we get it done. So with that, that'll close us out today. Thank you so much for attending TXAPA Live, our April 30th edition. We'll be back next week on Tuesday with our news and information program. Thank you for coming. Be safe out there, and make sure you keep washing your hands. Take care.
Thank you.
Guys.
All right.